So I would like to introduce you to Hieu. Hieu is a PhD student from the University of California, Irvine, currently advised by Athena. Oh, I should have pronounced that word before. Marco Polo. Sorry, Hieu, you're going to have to pronounce that one yourself. His research interests are ads and tracking and privacy, and his talk will be on revisiting Adblocking Circumvention. So, yeah, over to you, Hieu, and apologies for the mispronunciation there.
It's okay. Thank you for the introduction. And thank you for attending my talk on revisiting Adblock Circumvention. So publishers and advertisers are in an arms race with ad blockers. The goals for the publishers are to show ads and earn revenue, while ad blockers want to protect users' privacy and choice of not seeing ads. Now, what is Adblock Circumvention? For example, if a user installs an ad blocker, a website can use specialized techniques to bypass ad blockers to display ads. Notably, this is different than anti-ad blocking, as a user would be shown a pop-up that asks them to disable the ad blocker, pay for a subscription, or to whitelist the site. Circumvention has spawned third-party providers like Publica and AdThrive that can integrate directly with providers has spawned providers to integrate directly with publishers to circumvent ad blockers. They mainly target ad block users to recover lost revenue. And we separate circumvention into two types, cloaking-based and obfuscation-based circumvention. For cloaking-based circumvention, research has shown that WebSockets were used to bypass ad blockers due to a browser bug that prevented filter rules from blocking WebSocket connections. And another technique uses DNS CNAMEs to cloak third-party requests as first-party. Now, the drawbacks to these approaches are that they can be neutralized. For example, once the browser bug was fixed, WebSockets approach was no longer effective. And uBlock Origin already uses the DNS API from Firefox to identify third parties that use DNS CNAMEs. Now, due to these drawbacks, we focus on obfuscation-based circumvention. A general workflow entails first JavaScript detecting an ad is missing, would then send an obfuscated ad request to a circumvention server, and the server knows how to handle the obfuscated request, and it will contact ad servers to get the real ad content. It would then obfuscate the ad content again before sending it back to the browser. Now, JavaScript knows how to deal with this obfuscated response to rebuild the ad content and reinject it back into the ad. Now, in terms of circumvention techniques, they can entail randomizing URL components like subdomains and paths for outgoing and incoming web requests. So this corresponds to steps 2 and 4. They can also alter the DOM structures for ad elements to make it harder for filter rules to target. Now, which this affects steps 5 and the results of step 6. Publishers can integrate with CV providers to load ads as first party. So this corresponds to steps 3 and the results of step 6. So obfuscation-based circumvention is powerful because it leverages the pain points of ad blockers. For example, filter rules need to be specific to prevent false positives, and filter lists are static. Their effectiveness depend on how often they update. Now, in response, ad blockers have improved their filter rules. For example, we can now block the execution of JavaScript. So this affects all the steps within the browser here. They can also target DOM elements by looking at visible text. So this affects the results of step 6. And they can also watch specific DOM attribute changes, which affects the DOM activity from before steps 1 and after step 6. Unfortunately, the effort against circumvention has been fragmented. For example, EasyList and Easy Privacy do not support all new features, such as aborting JavaScript execution. Ad blockers also use different syntax and terminology for their filter rules. And despite some collaboration between filter list authors, the ad blocker still must convert other filter rules into their preferred syntax. Now, for Adblock Plus in particular, as far as I know, they have created a team to focus on circumvention, an entirely new list called the Anticircumvention List. I have studied this list in depth and had the pleasure to interact with eyeo to learn more about anti-circumvention. Now, because of this concentrated effort, I will focus my analysis on the anti-CV list. Now, what makes the anti-CV list special? First, it can be updated per hour versus every 4 days for EasyList. And when we look at the filter rules, we first note that some rules are compatible with EasyList and anti-CV list. We denote these as simple filter rules. Now, there are rules that are only compatible with the anti-CV list, and we denote these as advanced rules. Now, we now use the GitHub history of the anti-CV list to understand the progression of the effort over time. So the x-axis here ranges from May 2018 to May 2020, and the y-axis shows the number of filter rules for a particular day. We further break down the filter rules into different types for simple and advanced, like we discussed before. First, we noticed that within 2018, simple element hiding dominated. So this kind of denotes the fact that the filter list at the time could only hide circumvented ads, but not prevent them from loading. In November 2018, JavaScript aborting rules were introduced, which brought on their popularity in 2019 and onwards. So now JS-based blocking gives ad blockers the ability to prevent circumvented ads from loading. We also look at the time between commits to understand how often rules are being updated. So we find that the most common time between commits is 4 minutes, and on average, it is 8.7 times faster than EasyList. When we look at the commits per day for filter list authors, we find that it can be as high as 8 commits per day, and the number of main contributors is about 1/3 when compared to EasyList. So we conclude that the human effort is high for 3 main challenges of anti-circumvention. First is monitoring specific sites of interest. So filter list authors must constantly manually check sites to know when to update the filter rules. And discovering new sites with circumvention is challenging because you have to check thousands upon thousands of sites. And of course, filter rules need to be updated frequently to be effective. Now, there are some possible solutions to these problems. For the first two, we can use crowdsourcing to help with manually checking sites. However, crowdsourcing may not be feasible if the frequency increases, such as checking every hour. And it may not be scalable to check thousands of sites for discovery purposes. For the third problem, we can rely on perceptual ad blocking. So perceptual ad blocking doesn't use filter rules, but it does look at the images to classify whether an image is an ad or not. However, perceptual ad blockers can only hide ads, and so they don't protect the privacy of users since ads are still being loaded. Thus, filter rules are still necessary. And so our goal here is to reduce the human effort for the first two problems. So given a list of sites to monitor or a large list of sites to crawl, we pass them to our system. We call it CV Inspector. And our system outputs whether each site has employed successful circumvention or not. CV Inspector includes a data collection methodology and classifier. Specifically for a site, CV Inspector will crawl it for 2 cases, one with no ad blocker and one with an ad blocker. And it will collect data such as web requests, DOM mutation, temporal events, which are just timestamps, and the page source, which is HTML, inline CSS, and inline JavaScript. It then employs differential analysis to identify only the unique events that happen with an ad blocker. And we extract features from that set and put it through a classifier, which outputs whether the site can bypass the ad blocker or not. Now, our features map directly to the types of data that we collect. So for example, here, web requests, we calculate the entropy of URL components, such as subdomains and paths. Now, for example, if we look at the normal URL, we see that convertkit.com here is loading a JavaScript resource. When we compare that to the obfuscated request, it's hard to determine its purpose because the domain, subdomain, and path are highly randomized. For DOM mutation, we calculate the number of elements being removed for iframes and images, and the number of attribute changes, such as class, style, height, and width. For temporal events, we count the number of clusters of DOM mutation changes over time. So here's an example on top without an ad blocker. We see that there's only one cluster of activity that lasts for 4 seconds. Now with an ad blocker, we actually see several clusters of activity that spans over 20 seconds, denoting circumvention activity. For page source, we extract the number of iframes and images and add positions. So in order to do this, we first identify locations of third-party iframes on the no ad blocker case. And then we dynamically build CSS selectors for those locations. We then apply the CSS selectors to the page source of the with ad blocker, and then count the number of found iframes and images. CV Inspector has a performance of 89% when detecting sites that can bypass ad blockers and 94% when it cannot. We apply it to a list of interest provided by Adblock Plus for monitoring purposes. Here we achieve a score of 80% that can circumvent ad blockers and 99% that cannot. We also apply it to a list of top 20K for discovery of new sites with circumvention. Here we achieve a score of 87% that can bypass ad blockers and 97% where it cannot. In conclusion, CV Inspector can reduce the human effort in monitoring specific sites of interest and discovering new sites with circumvention. It can also be deployed frequently, like hourly, daily, whichever is necessary. And CV Inspector is scalable because multiple instances can be started with Amazon Web Services. So this work is currently under review, and we hope to make it available soon. And I would like to thank my advisor, Athena Markopoulou, and our collaborator, Zubair. And in particular, thank you to eyeo for providing insights into circumvention and sample data to evaluate CV Inspector. Thank you.
Awesome. Thank you so much. We have 2 minutes before the break, so maybe we can sneak in one question. A question from Jeffrey: how do sites prevent you from blocking the circumvention JavaScript?
How does site sites
prevent you from blocking the circumvention JavaScript?
Oh, okay. So I think that question is asking how, when app blockers employ JavaScript-based blocking, how does the site circumvent that? So basically, with aborting JavaScript, they look at particular either code that accesses certain APIs, and then they're like, okay, if this site is using this particular API, then just abort it. Or if there's a JavaScript instance that has a name, like say window.circumventing ads or something like that, then it can abort any JavaScript that reads or writes to that object.
Brilliant. Thank you so much. And thank you for your talk. I'm on the anti-CV team, so it's very close to my heart. And I know you've got lots of fans who are listening, so thank you.
Thank you.
And we're going to go into a 30-minute break now. So everybody can meet back here at 7 p.m. CET. Nora has been posting a link to the Slack channel in the chat. So if you'd like to follow up with some conversations offline, you're welcome to meet up there. But otherwise, we will be back at 7 p.m. CET. Thanks again, Hieu, and see you.